So we got this question to integrate. So the question is alpha equals integration from 1 by 2 to 2 tan inverse x upon 2x square minus 3x plus 2 dx. Now, you know that majorly we used to take help of substitution and we used to assume that thing as z, to which after differentiation we get something which is available in the question. So suppose that we have problem with tan inverse x. So if we will take z as tan inverse x, if we will do the differentiation, we will get dz by dx, and the differentiation of tan inverse x becomes 1 by x square, which is not available. It's different. So I don't think this tan inverse x taking as z will help us, guys. Okay, now, so we have this thing in the denominator. You know that if denominator thing you will take as z, you will never have tan inverse x, not even in your wildest dream, correct? But still we have to solve this question. So how we will approach these kind of situations? So look at this limit. If you'll observe the limit is reciprocal to each other. So if you will find these kind of situations, no, take x as 1 by z. Okay, and then look at the beauty how you will simplify things. So let's differentiate x. Differentiation of x becomes 1. Differentiation of z power minus 1 becomes minus of z power minus 2 dz by dx. So can I write dx as minus of dz by z square? Now let's simplify things. So we will have tan inverse 1 by z. So it will become 2 by z square minus 3 by z plus 2, and dx will be replaced by dz by z square with minus. You also know that if we will take anything as z, limit also get changed in definite integration, correct? So suppose that x is 1 by 2. So in that case, z will become 2, and if x becomes 2, z becomes 1 by 2. Now look at this lower limit. Lower limit is 2 and the upper limit is half. Means upper limit is smaller than lower limit, and we are not comfortable with these kind of situations. So what I want to do, I want to interchange the limit. So if you wish to interchange the limit, you can do so, but you have to introduce extra minus and then things are okay. So minus of minus becomes plus. Then you can interchange the limit 1 by 2 to 2. You also know that tan inverse 1 by z becomes cot inverse z, because 1 by z is a positive number. So if 1 by z is a positive number, it's okay, totally fine. If you will take LCM, denominator will become z square, and also we have z square this, so this thing will be neutralized. So let's focus on the denominator. So it is 2z square minus 3z plus 2 dz. Now suppose that you wish to just replace the variable z. Okay, means we are comfortable with x, not z. So what you can do, you can directly replace z with x, or take z as x and then do the differentiation, you will get the same thing. So we will have 1 by 2 to 2 cot inverse x upon 2x square minus 3x plus 2 dx. Now look at the equation 1 and equation 2. Both are alpha. In both the definite integration, lower limit and upper limit is same and denominator is same. The variable parameter is also same. So can I say that I can add both the equations? है ना? So if we will add both the equations, we will be having what? We will be having 2 times alpha integration from 1 by 2 to 2 tan inverse x plus cot inverse x, tan inverse x plus cot inverse x. Denominator is same, so we don't have any problem with that. 2x square minus 3x plus 2 and dx. I hope till this part you guys are okay. Now, you know that tan inverse x plus cot inverse x is nothing but pi by 2. So can I take that pi by 2 constant outside? And I want to send this to that side. So it will become pi by 4 integration from 1 by 2 to 2 and then dx by 2x square minus 3x plus 2. I hope till this part you guys are okay. Now, if you will observe the denominator, we are having quadratic and you cannot factorize this quadratic. If you will factorize this quadratic, we can apply the concept of partial fraction, है ना? But we are not able to factorize this thing. So what we will do? We will do completing the square method. So we have, first we will take 2 common. So we will be left with pi by 8 integration from 1 by 2 to 2 dx by x square minus 3 by 2 x plus 1. Now we will do the completing the square thing. So we have a square and we will make this thing as 2ab. So minus 2, according to us a is x. Now I want 3 by 2x to become 2ab. So 2 is 2. According to us x is a and we want b. So can I like simplify things so that this x gone. So value of b becomes what? 3 by 4. Okay. So we will write value of b 3 by 4. Now we got a square, we got minus 2ab. Now we want b square. So 3 by 4 whole square added. Now if you will add this thing, the equation will become unbalanced. So you have to make it balance, you have to remove 3 by 4 whole square and then plus of this 1. Okay. Now can I write these three things as x minus 3 by 4 whole square? Now there we will be having 9 by 16. So 16 minus 9, 7 by 16. Can I write this thing? So we did that completing the square method. So alpha becomes pi by 8 integration from something by something dx by x minus 3 by 4 whole square plus root 7 by 4 whole square. Now, don't you think that it reminds you of what? It reminds you of tan inverse x. Okay, so denominator is something square plus something square without root. So if it is without root and if you are comfortable, if it is without root and you are comfortable, you should go with 1 by a. If it is without root and you are not comfortable, you should go with 1 by 2a. And if it is with root, directly you have to initiate the formula. No need to write a and 2a. So in this case, this is without root and we are comfortable. So we are comfortable, we will be writing 1 by a. So a is this. So we will be writing a as root 7 by 4. And then tan inverse x by a, है ना? Who is x? X minus 3x by 4. 3 array. Wait. 3. 3 by 4 by root 7 by 4. Okay. Now we have to put the limit. What is the limit? Limit is 1 by 2 to 2. We will do the simplification part. Let's do it. So alpha becomes pi by 2 root 7. Now we will put the limit. So we will have tan inverse. Now we will be writing x as 2. So 4 2s are 8, 8 minus 3, 5. So 5 by 4 and denominator is root 7. So can I write 5 by root 7? Okay. Minus lower limit. Then I will be writing tan inverse, then it is 1 by 2. So 1 by 2 is 2 by 4. So it is minus of 1 by 4. So it is minus of 1 by root 7. Correct? So this is what we got. Now do little bit more simplification. So alpha equals pi by 2 root 7. Now you know that tan inverse minus theta is minus of tan inverse theta, because tan inverse theta is an odd function. Okay, so we can take this minus outside, it will become plus. Okay, we are almost there, just write. So we have tan inverse 5 by root 7 plus tan inverse 1 by root 7. Now here we got tan inverse x plus tan inverse y. So can we apply tan inverse x plus y formula? X plus tan inverse y formula 2 root 7. Then we will be having tan inverse, it is a plus b, है ना, 5 by root 7 plus 1 by root 7 upon 1 minus 5 by root 7, 1 by root 7. Let's write down these things. So pi 2 root 7 tan inverse. Now you know that the numerator becomes 6 by root 7. Okay, so 6 by root 7, this is 7 minus 5, so 2 by 7. So it will become 3, it will become root, है ना, and the denominator root will go to the numerator because it is like it is looking ugly, but I'll help you. Wait a moment, I'll help you in another way. Look at this. Can I write 5 by root 7 divided by 7 minus 6, sorry 5, 7 minus 5 by 7, है ना, pi by 2 root 7 tan inverse. Now this is 5, this is root 7, multiply 7 by 2. Okay, 7 by 2, it is 6, no, it is 6. Now this thing is 3, this thing is root 7. So we got our thing. So pi 2 root 7 tan inverse 3 root 7. Now what do we want? We want root 7 times tan inverse. Acha, we want 2 alpha root 7 by pi. So look at this. This is alpha. Acha, 2 alpha root 7. So if we will multiply both sides by 2 root 7, we got, and then divide by pi. So we will get almost the argument of tan. So we got 2 alpha root 7 by pi equals tan inverse 3 root 7. Now we will take tan both sides. So we will be having tan 2 alpha root 7 by pi equals 3 root 7. Now they want to, this thing is done. they want to have extra root 7. So what we will do, we will multiply root 7 both sides. So we will get 21. Therefore, the required result is 21. Okay. So the answer to this question is 21. I hope the idea is clear, and from now onwards, if you will witness the limit to be in the form of a and 1 by a, you can apply this logic. Okay.